title of the project is Incident Angle Correction of SAR Sea Ice Data based on locally linear mapping. Here a locally linear mapping is taken to correct the incident angle which happening in the SAR Sea Ice database. The SAR Sea Ice database is a satellite image to monitor the sea ice by using the locally linear mapping. Here the term backscatter means it has a angle of radiation at 180 degrees Celsius. The incident angle effect is taken. This incident angle will help us to scan the synthetic aperture radar, that is scans SAR. The term SAR is synthetic aperture radar, which will help us the mapping process to monitor the sea ice. In this project, a glass-based correction is proposed for the normalizing each glass in the scan SAR to a nominal incident angle. This incident angle effect will constrain the application of this scan SAR to monitor and observe the sea ice. In the previous system, they add a data set for the Gulf of St. Lawrence, which is obtained by the radar SAT-2 satellite. From this satellite, they obtain the data set of this Gulf of St. Lawrence, and this data set for the Boise Sea, which is obtained by the NVI SAT-AD Advanced Synthetic Aperture Satellite. This satellite is helped to get the data of this Boise Sea. Here the distribution of backscatter. Already I told backscatter is a angle of radiation at 180 degree. So the distribution angle of the radiation of 180 degree will be coefficient with the discrete as well as non-linear, and this class based will depend on the mapping process of locally linear mapping. The disadvantages of this existing system is the backscatter coefficient is very low because it has the angle of radiation is 180 degree. To overcome this limitation, in the proposed system, they used a geometrical optics based SAR correction using database. Instead of using the backscatter, this geometrical optic based will help us not only take the angle of radiation 180 degree, it will consider all the angles obtained in the image. The advantages of this proposed system is here the difference between the corrected backscatter coefficient as well as the SAR images will be clarified and compared the areas where the same thing happening. The application of this project is the linear mapping is corrected by using these scan SAR images, which is help us to get more detail of the structure as well as the natural signal variability where the radar data is preserved. The software requirement of this project is MATLAB 2014A, and the tools used in this project is image processing and computer vision. The technique used in this project is overview of the available techniques. The overview of the available technique is already we see that the backscatter coefficient. Here the pixel by pixel, the each incident angle will be taken as a 180 degree, and this 180 degree will get into the picture from the satellite so that we can detect where the sea ice is present. So it will help us to get into a, while the ship is going, it can't able to met the accident with the sea ice. And another technique they used is linear mapping technique. That locally linear mapping will get into the image from the satellite and it will map the present area. So both the areas should be present as the same area and it will detect. The future work of this project is, in this system they used a k-mean. In future we can use the k-mean algorithm. The term k-mean algorithm means it's a constant clustering image. The every part taken by the satellite will be determined by this k-mean clustering image. So in our future we can use this k-mean algorithm, that is constant clustering image, as well as we can also detect our see to the ship itself. The satellite only detect in this project, but in our future we can also help the captain who is in the ship is easily and currently detect what is coming in front of the ship. Instead of using this LLM method, we can use that k-mean method in our future work.